In this tutorial, we are going to look at calculus, and our main focus will be on continuity of a function. So you might be given a certain piecewise function, then you are asked maybe to find or determine whether the function is continuous or it is discontinuous. Discontinuous meaning non-continuous, right? So you can be given a piecewise function. A piecewise function is just a function which has different expressions, okay, or different formulae or different domains. That is what we call a piecewise function. So how can you apply the concept of piecewise function in determining the function whether it is continuous or non-continuous, or it is discontinuous rather, right? That is non-continuous. And also, how can you prove or show, and can you sketch a certain piecewise function? So this is what we are going to explore in this session. So stay tuned as we propound this concept. So let's say I have a certain function. Let me say the function I have is f of x. So this is a piecewise function. I'll say 2x plus 1. Then this is if x is less than or equal to -1. Then I'll also say x squared minus 2. For this one, it is if x is greater than -1. So how can you solve these questions? So the first one is determine if this function is continuous at x equal to -2. Okay, -1. So the first question is the function continuous? Is the function continuous at x is equal to -1? So this is a question. Then the second question we have is find f of x. So let me go to the next slide. So I'll say b. In fact, let me even have another slide already. Okay, so our b is find limit as x approaches to, or the function f of x. Then the last question is sketch the graph of f of x. So how can you solve these questions? Let's start with the first one. F of x is equal to, that is the function continuous at x is equal to -1. So the best way to solve piecewise function is first to sketch. When you want to determine whether it's continuous or non-continuous, it is discontinuous, you need to sketch. Okay, let's start with sketching first. So in order to sketch this function, I'll have my x and my y. So that is y axis and my x axis. So the function which I have is, the first one is 2x plus 1. How do you sketch 2x plus 1? So when you want to sketch 2x plus 1, so 2x plus 1. When we want to sketch this, y is equal to 2x plus 1. This is just a straight line. You just test. Let's say I test 0. What will be the value when x is equal to 0? My y value, so x is equal to 0, my y will be 1. So to be 0, y is giving 1, positive 1. So somewhere there. Then I test another number. Let's say, which number can I test? Any number. Let's say maybe if my x is equal to 1, my y will be 3, right? So that is 2 times 1, that is 2 plus 1. My y will be 3. So I have 1, 3. 1, 3 is somewhere. Okay, this time around, let me use something negative so that I get to know where the line is passing. Let me use negative. So what if x is equal to negative 1? What will be the value of y? So the value of y will be, that is negative 1 also, right? So negative 1, negative 1, somewhere there. So negative 1 there. We have negative 1. Even there we have negative 1. So somewhere here. Okay. So how do you get to sketch now? So they should be, the line should pass like that. At negative 1, 1, and also at 0, 1. So this is how the line should be. But remember, we are told from this domain that our x should be less than or equal to negative 1. So this is what we are going to do. Instead of having a line, okay, instead of having a line going up to that point, we've been told that x shouldn't be greater than negative 1, should be less than or equal to negative 1. So we are going to end at negative 1, then going down. Okay, so let me use a different ink to show this. So it is at negative 1 because it is less than or equal to. They said x is less than or equal to negative 1. So I'm going to shade this. Negative 1 going down. This is where my graph should go. I'll shade that negative 1. So I need to shade to make a dot. Okay. Alright. Then the next equation I have. So this is my x-axis. That is my y. So the next equation I have is x squared minus 2. X squared minus 2. How do you sketch this? So I have x squared minus 2. X squared minus 2. So there should be an arrow there. X squared minus 2. Like that. How do you sketch? This is a quadratic. So it means that the turning point is at negative 2. And because this is a minimum, it will face upward. So at negative 2, let me just extend this using maybe red ink. So at negative 2, there, that's where we are expecting a graph to go like that. Okay, the turning point is at -2, so it should come like that, then it goes like that. But you see, so let me just use dotted. The graph should go like that. But we've been told that x should be greater than -1. So starting from -1, okay, so starting from -1 there, that's where the graph should start going to the positive x-axis, because the domain we have is x should be greater than -1, so should go like that. We won't go to the negative part because it should be greater than or equal to -1, so the graph will go like that. Okay, so that will be our graph. So this is there is a dot. This is how you get to sketch this piecewise function. Then the next thing, we need to determine maybe the value there. To determine that value, you consider it was x squared minus 1. So in the x-axis, y is equal to, so this is equal to y. So y is equal to 0, so it will be x squared will be equal to +1, because y is equal to 0. We find the square root. Or it was -2, sorry. So we find the square root of 2. So at that point is just square root of 2. So there it is square root of 2. That is the point there. So we've sketched this graph passing at -2 as the turning point. Then the next thing, let's determine whether this is continuous. So let's start with finding. So for us to determine whether it is continuous, there are certain things we need to consider. First thing, we're going to find what is f of x. If we find f of x, we need to make sure that f of x should be equal to limit let me have a different slide. Okay, so this is what we are going to do. The first thing, we're going to find the limit as x is approaching -1 from the left and from the right hand side, okay, of this f of x. Then we also determine what is f of x, f of -1 in short. What will be f of -1? Then we are going now to compare if this limit of f of x will be equal to f of x. If they will be equal, we are going to say this is a continuous function. So let's determine what is f of x. Let's start by determining what f of x is. So f of x will be equal to, they said at -1. So the one which includes -1 is this one, which has less than or equal to -1. Okay, so the function we're going to use is 2x plus 1. So I'm going to substitute -1 in this function. So this will be f of x is equal to 2x plus 1. Then we substitute x is equal to -1. So I'm going to have f of x will be equal to 2, where there's x negative 1 plus 1. So this will give us what? Negative 2 plus 1, that is just negative 1. So we've found that f of x is equal to negative 1. Then the next thing we're going to do here, so let me write it somewhere. So f of x is equal to negative 1. So that is the first answer we found. Then the next thing, we're going to find the limit from the left and from the right side of the graph. So let's find the limit as x is approaching negative 1. Let's start from the positive of this graph, or we start from the negative rather. From the negative of this graph. So we'll follow this graph from the negative. So we are coming from this side. Well, let me use a different ink so that okay, so we are coming from this side, negative part, then approaching negative 1. Negative 1 is there where we had the dot. So as we are approaching negative 1, the limit is what? It is still negative 1 there. Okay, following this line from the negative axis, as we approach, it is still negative 1. That is the limit. So we're going to have the limit is still negative 1. What about the limit from the positive axis? The limit as x is approaching negative 1 from the positive or from the right side. So we follow this graph, we come with it approaching negative 1. It is still giving us negative 1 even from the right. Okay, so that is the limit. So it is still giving us negative 1. Then we see that the f of x, it gave us negative 1. It is equal to the limit as x is approaching negative 1. From both sides, the limits, we're just going to conclude that the limit as x is approaching negative 1, it is just negative 1. And we see that f of x is equal to the limit as x approaches 1. For that reason, and the answer is giving us 1. So we are going to conclude that this is continuous, because f of x is equal to the limit of the function f of x as x approaches negative 1. So it is continuous at x is equal to negative 1. So this is how you get to determine. What is the next question? The next question is, we've sketched this. So the next question is this one. Find the limit of the function as x approaches 2. As x approaches 2, which one are we going to take? The one which will include 2 is this one. The domain is x is greater than negative 1. It includes 2 because all the values of x greater than 1. So we take this function which is x squared minus 2. So this is the one which you're going to take. So I'm going to say the limit as x approaches positive 2 of f of x will be equal to the function we take is x squared minus 2, right? So we get to substitute where there's x, we substitute 2. So it will be 2 squared minus 2. 2 squared is 4. 4 minus 2 will give us positive 2. Therefore, the limit as x approaches 2 will be equal to positive 2. So that is how to find the answer. So this is where we end. Thank you for watching.